Now I want to clean out the pivot holes, and I'm going to do it with one of these little orange sticks which Time for Clocks told me about, so that's what I'm going to do it with. I've impregnated it with a bit of isopropylene, which is a cleaner, and I'm not sure if I think I've taken the worst of it out, and when you put a drop of oil or so in, as soon as less than a drop, when you oil it, it'll be a bit different. Right, so we're working from the front plate. They're pretty clean. That's right. So, just checking. Oh, that doesn't seem to be home properly. It's not quite right, but that's better. I can now put the plate on. And start fiddling around to get them in. To do that, I'm going to put this on a table and lower my seat so I can look up and see what I'm doing. So when I've done that, I'll reconnect. Right, here we have the motions, and I'm just going to put it together. shake. They're all maybe well and well. So now let's have a look to make sure that no pushes are required. And they're all very tight. When I say very, very tight, they're perfect. As you can see, there's no natural movement of any consequence in there. The knob is okay. So, very happy with that. But this is very good quality. So I would assume that it's way back in 1900, probably before, because the thickness of the plates are generous. No, I mean, you don't need plates that thick unless you're really making something of good quality. They're usually 1.5 millimeters, and these are 2.25 millimeters. So I will now progress and put the arbor in, scratch at the back, and then build up the front, and I'll come back later. Well, I've now assembled it, and I've put it on my leveling table to make sure that it's level all ways. I'll show you later. And you can see that it is working quite happily. Well, I wouldn't say happily, but it's working. The arbor palette is registering well in here, which is now quite clean. The pendulum is swinging easily. It was a little bit difficult because during my cleaning process I'd altered the position of this in relation to the arbor, which meant that it took some fine adjustments to get it to respond and to react properly. So it's in my makeshift Heath Robinson system of suspending the clocks. It'll probably stop now because it's wobbling around, but there's the front. It's all together. That's just to keep the clock upright, as it slips back otherwise. Still working under protest. And here we are. There's the pendulum in the back. Stopped for the moment. Doesn't like swinging around. It's working. So that's another step we've made. I'll compare it to the what it was like to begin with. I'll see if I can split a video to compensate this, to show what it was like. Right, now the table upon which I put the clocks to test them is this table here, with an arrow pointing the direction it should be facing, because the surface upon which it's put is not level, and as a consequence, if I don't have this in the same orientation, then of course it's not going to be level. This is only level to the desk in this particular orientation. And this is so, that way and that way. So that means that I've got a dead right datum to work from, which is quite important. In other words, when I set the clock up and I get the pallet here, the anchor pallet, in balance with the escape wheel on this particular surface there, then that is a situation where the clock and the pallet and the pendulum are all in harmony, and the pendulum will be pointing directly to the Earth's centre of gravity. And that means that that's a datum from which the clock in any circumstance will be registering properly when it's level. If you've got some clocks, then you have to tilt them one end or the other because they're designed with the clock fixed inside the casing, and it's the only way that you can do it. With a French clock, I've pointed this out in other videos, with a French clock, if you twist it, if I twist this on this little frame that I've got here, it alters its position in relation to the centre of gravity of the Earth. Now I move that and it mucks it up. If I come back and I get it to work properly, let's see if I can get the balance there, move it the other way and it stops because you're upsetting it all. So equally, if when I've got it working properly, I then, let's see, I then lift it on one way or the other, one side or the other, then I've upset it again and it'll stop. It's stopped. Pendulum's still swinging, and if I put it back there it should work, but if I lift the other side, again it'll stop. Equally, if the clock is not level and you lift one side up, then it may work. I always use this, which is a cheap mechanical engineering stethoscope, which you then listen and you just put it onto the wood or the clock and you can hear the beat, and you hear it so clearly that you're not going to get confused with any other noises, and you can then, in the case of a French clock, twist it slightly in its case where it's going to rest, and you get it in beat. And that's the reason why you can get it in beat. If the clock is going to be balanced by a professional and he sees it in a place where it's not going to be level, then instead of putting things on one end or the other, the horologist or the clockmaker can alter the angle that this anchor pallet, anchor pallet is, because it will move on its arbor. And in fact, that's what I did when I cleaned it. I moved it and it was way off, and the pendulum couldn't hang perpendicular. So some people recommend that what you do is correct it to level it by, when it's in its case, holding that and moving this, which will actually alter the anchor pallet in relation to the escape wheel. But you've got to do that blind, because you've got to put your hand inside the clock case. You can't see what you're doing, and in all probability you'll muck it up and find that you're lost. You're not quite sure where the datum is or where that you should start from, and unless you're skilled, it's not a good idea to do that. Anyway, that's be that as it may. I've learnt that as a novice, and if you're doing it, then that is a situation that you can get to, where this arbor here, and I'll focus on it, with the anchor pallet on it there, will turn on this brass bearing here, which has got a thread on it, so you can move that in relation to the arbor or the pin at the end, and that will mean that you will have a new say center of gravity. You'll have a new balance for it. But the way that I like to do it is to get this right on that, when it's on this table, when I know it's horizontal, when I know it's level, and then I know that from that point any alteration is going to be one which will be trying to observe the true datum that you've set up. If you do it the other way around, you're lost. You haven't got a way to go. And as I said, you can hear the beat with this, with these engineers' stethoscope. They're very cheap. I think this costs probably somewhere between £6 and £12. Goodness knows where they're made, but they're certainly not made in Sheffield. Unfortunately, they're probably made in China. So there we are. I'll leave it running, and it'll be on test now. I've just got to get that in beat properly with my stethoscope. It'll be on test, and I'll leave it running for a week or so.